Ed, how you doing?
Hey guys, good to see you.
What's going on? Nice to meet.
Would you mind just kicking it off with a little background on the company, maybe how you pronounce it? It's Machina Labs, right?
Yeah, you're right, Machina Labs.
Fantastic. And yeah, just give us a brief overview for the listeners.
Yeah, for sure. I think Machina Labs is a response to something that maybe actually Peter Thiel said once, right? I don't want to butcher it, but it was along the lines of like, we wanted flying cars. We ended up getting, 140 characters, right? Which kind of comes down to the cornerstone of like, okay, software develops really fast, hardware doesn't. I think, some people interpret that as as something that says, oh, like we don't have as much gusto in the hardware side. But reality is there's a lot of technological challenges in terms of building hardware, right? So what we're trying to do at Machina Labs is just making that much easier, right? If you're a software developer, two people can develop a program, rent server from AWS, Amazon, deploy it. If you want to build a hardware, you pretty much have to go build a factory, right? And that's why development timelines are like 7 years, 9 years. So what we're doing at Machina is we're using robotics and artificial intelligence to build basically what we call a robotic craftsman. And it's a robotic system that can do different types of manufacturing operations. And it's powered by AI, basically can figure out how to pick up different tools, do different types of operation to make different types of parts, physical parts, without anybody having to program it or having to handhold it or build tools for it.
And can you talk about the specific kind of like first instantiation of the thesis? I saw Justin Lopas over at Base Power posting, and it looked like he used a picture of your warehouse. Is that you guys? Is that right?
That is us.
Okay, and so he breaks the new manufacturing space down into 3 categories: manufacturing SaaS companies, make parts for other people companies, and change the way the part is made companies. And which one do you guys fit in? I think you're in the third, right? Change the way the part is made, developed a way to make stampings, complex geometry form sheet metal parts without dies. And so can you break us down, like what is actually going on when this massive robotic arm is like pushing into this metal? Explain why this is important, how it works.
Yeah, so we wanted to build a system, we call it a Robo Craftsman, right? But the idea is like, where do we get started? And we started as sheet forming. Sheet forming is the largest metal processing sector today. I think it's like $280 billion industry. Most of the metal parts you see day to day are sheet metal parts. Like, you're sitting in your car, you're in a sea of sheet metal. Every other car body is sheet metal, form sheet metal parts, or aircrafts are basically sheet metal cans. But today it takes a very long time to get your first batch of parts in sheet metal world, right? You have to go make dies, put them in giant stamping presses, like 4-story tall buildings. And then stamp your parts out. So our first kind of application of being sheet forming, we have 2 robots that form, start from a flat sheet of metal. Between 2 robots, they have these giant fingers that are super strong, but they can basically push and pull on the metal that form it into a very complex shape without the need for any dies or tooling. Basically, you get from idea to the first part in a matter of hours, right? It's similar to how a potter forms a clay bowl with their fingers. They're coming into the sheet, they form it, and shape it into different shapes. So yes, it's a new paradigm, a new way of doing manufacturing, but it doesn't stop there. We're already doing like trimming, we're already doing slotting, hole making. So the robot can literally pick up another tool, figure out what it needs to do with it to do the next operation, and does that. So today it does forming, it does a lot of subtractive work like trimming, hole making. It also does a lot of QC.
Do you get worried? There's been an explosion of new manufacturing startups over the last couple of years, long since you guys started the company, many of which promising to automate with robots the creation of various products. We covered earlier today on the show just how hard it is to for Nike to manufacture a shoe, right? Which sounds somewhat trivial. Like, humans have been doing them for years. You should be able to, maybe we should be able to do it with machines, but then in practice, it's like there's so many different factors down to temperature. Out of all, when you look at manufacturing broadly, I'm assuming you have some type of framework for evaluating whether something like can be automated to the degree that people would like to see out of manufacturing, or areas that, are basically shouldn't be touched, right? Like something like shoes, which have infinite sizes and a bunch of different factors.
Yeah, I think it's like a combination of like three things, like the market size, opportunity, and how technology ready it is to be kind of disrupted, right? So, um, uh, but also I think there's a lot of conversation around automation that is in the previous paradigm. I think for now, for the first time, we have this concept of LLM, this concept of we can actually reason very complex sequence of operations as long as we can train the robots on that sequence of operations. So it comes down to what data do we have available to train the robots. We already figured out, okay, neural networks, LLMs, these transformers, if you give it enough data, it can actually learn a very complicated task. The real key was, okay, where do we generate enough data? Where do we have enough data to train it? So it needs, and unfortunately for a lot of manufacturing tasks, the data is not out there, right? You cannot train a very complicated model on it. For ChatGPT, the internet had trove of free data that you could use to create a very complex kind of chatbot. For us, coming up with right sequence to make car doors or shoes doesn't exist.
Yeah.
So the key is, can you actually provide a solution that can scale with limited amount of data, with human intervention and limited amount of data, so you can deploy it in the field and get enough traction, so we can have now enough data that comes from your machines to train your model.
Can you talk
and that's why we went after sheet forming.
Got it. Can you talk a little bit about the NVIDIA announcement today? That's very exciting. Seems like it might be a little bit of like a side quest, or is this like in the critical path to mass production?
Yeah, no, NVIDIA's today announcement was a kind of little fun thing we did. NVIDIA is an investor in us. So
cool.
Fundamentally, they are very interested in what we are trying to do, being able to capture data from physical phenomenon and build models that can manipulate the physical world.
Cool.
But I think we work with their artist in residence. It's actually that's OpenAI's artist in residence that we work with NVIDIA collaboratively to really turn just the artist speaking to a system into a piece of art, right? So Alex, the artist that will work with us, basically spoke what he wanted to build, what sculpture he wanted to build, and the full stack of generating the code, running the robots, all were done autonomously. So from speech, from intent, all the way to the physical part, without anybody ever touching anything.
I love that. I was when the Studio Ghibli moment happened, I was taking some photos of like my kids' play sets, Studio Ghiblifying them, and then immediately I wanted to print them out because I wanted to have some sort of like physical instantiation. Just showing the phone was like not satisfactory. So the idea of like speaking words and then getting like a sculpture out, like that sounds really awesome and futuristic. Yeah, go.
How there's a lot of investment in humanoid robots lately. Many of those promising to revolutionize manufacturing, replace human labor, automate the production of lots of things. As somebody who's been doing it with robots since 2019, how do you think of that form factor in the context of manufacturing?
Yeah, I'm actually super bullish on humanoids, right? I think the question is, to your point, is the first application going to be in manufacturing? I don't think so, right? I think the biggest problem, if you want to like think of a startup as like, what do you need to de-risk first? The first thing, you give an example of like Nike figuring out how to do the shoe manufacturing. The first thing is actually intelligence. We had kinematic frameworks for a long time. We could do what humans does in terms of kinematic freedom with industrial robots. We can actually do it more precisely with higher force with industrial robots, which was what we need in manufacturing setting. So the missing piece really was intelligence. So we're kind of a little bit intelligence first, right? We don't need to solve the joints. We don't need to solve people walking around, like robots walking around and having the human form factor. If you solve the intelligence, you have enough kinematic frameworks, which is industrial robots, to do what you need to do. But that being said, I think humanoids is a huge opportunity. Maybe not in manufacturing, but downstream in homes and all other places that we can use humanoids.
What is the I imagine you guys are a beneficiary from some of the tariff stuff in some way, but on the actual machine side, are you in the industry seeing challenges of like how much of like the actual robots that you guys are leveraging are sourced outside of the country? And
Chris at Hadrian was saying like, my CapEx goes up by 10%, but the demand has been way higher. So what's been your experience?
I mean, that's true. I mean, like what we do here, the challenge is for a lot of work that we do, and especially in the defense, aerospace defense, there is no industrial base. So we have to do it. So the demand is always there. Now, 70% of our BOM is off the shelf. And we intentionally try to do that so that we can actually finance it easily, right? Use multi-push repairs, off-the-shelf equipment so that we can easily finance the full hardware stack. That being said, a lot of the hardware that we use is either produced in America or it's in very like allied countries. For example, robots are produced in Japan. So the tariffs are a little bit more digestible there. But that being said, we are one of the very few manufacturing companies that are like doing almost software-like margins. So there is enough room for us to be able to absorb that cost and still, have a very high value, high margin business.
Interesting.
Is the idea on that note? Is the idea we've seen some investors kind of strictly software investors kind of poke fun at VCs that are investing in manufacturing, expecting software-like margins, and there's sort of this sense that manufacturing for most things hasn't historically had software-like margins. You're seeing it today. How do you think about the margin profile for advanced manufacturing over time, even in things that are like non-chips, right?
Yeah. So it's interesting arbitrage. I think there's a lot of people thinking about manufacturing solutions in different ways. I think you can think of it as automating what traditionally has been done, and I think that's usually end up being very low margin, right? But if you're creating something new that has some kind of arbitrage on either labor or has some kind of arbitrage on equipment, right? In our case, whereas you don't have to make dies, right? And a single die for a car door can be up to $1 million, right? So for us, we're faster, but we get rid of that asset. So it allows us to have at the same cost parity, have higher margin. But I think, down the road, the margins could erode. And that's why we're thinking about it as a platform, right? It's a robotic system that can do forming today. Tomorrow, it's going to do your next operation. It's going to do bending. It's going to do hemming. It's going to do forging, right? So you're constantly expanding the capabilities of the system, which allows you to sustain a very larger volume business as some of the margins of the older processes kind of erode, right?
Makes sense.
Yeah, last question. You mentioned that you might have a Golden Dome take. We did a little deep dive. There wasn't a lot to dig into. I'm curious. It doesn't seem like it would interface with your business too much, but maybe you just have studied the industry. So what do you think is going on with the Golden Dome?
He's
right
making an actual dome.
Dome, yeah, make a physical
out of
dome
gold to go over the United States.
I would love that.
If you like the blue, enjoy the blue above us while you can. It's going to just be all gold soon.
Yeah,
that's right. I mean, there was people were talking about how it's competing with a Golden Dome at Notre Dame, which is actual thing in terms of the naming conflict. No, so why do we actually fit into this paradigm? We work a lot with missile manufacturers, right? And manufacturing components for them, the body of the missile for them. Hypersonics is one of the main enablers of how we can actually have defense against some of these missile attacks. So for hypersonics, you need to start processing very complex materials, materials that were traditionally very hard to process. Think of high temperature alloys like nickel, titanium. And because of our robotic process locally manipulates the material, we have way more control to process the material without getting to failure. For example, we can form titanium sheets without tearing it at room temperature, which is traditionally not possible, right? So I think there's a lot of interesting opportunities there for us, and we're exploring with our primes that we work with. But yeah, I mean, the whole concept of Golden Dome is going to be interesting. What I've heard last is it's going to be 7% of the DoD budget in the next 2-3 years, right? Once it becomes programmatic. Yeah, so that's what I've been great. Obviously, next year we're looking at I think $20 billion on missile defense, but over long term, I think the plan is roughly 7% of defense budget. So it's going to be a huge opportunity, and obviously, I think something that's probably very necessary for America. But yeah, we can dive into details, but I don't know how much time we have.
No. I mean, I think we'll have to have you back on when there's more details that emerge and we actually get, a deeper dive into how the how the program of record evolves, what the subcontractors might be looking at. Right now, all the names parties are no comment, so there's not too much to dig into for good reason. But it'll be super interesting to see how this pans out. Jordy, anything?
No, this was great.
Yeah, we got to have you back on soon. But congratulations on all the success, and I'd love to come see the machines in action in person.
Yeah,
Yeah,
we
you
really-
should come.
amazing.
You know,
Yeah.
we're half an hour away from downtown, so downtown LA. So both,
awesome.
both of you.
Yeah, that'd be awesome.
extending
Let's do it.
invite.
I want to do the show with a robot. You
I
know,
want a
handing
robot to
John
make us a bigger
Celsius.
gong.
Yeah,
the
yeah,
biggest
yeah. We
gong
need a-
possible.
Gotta make it happen. We gotta
Yeah,
make it happen.
that'd
That's
be
something we
fantastic.
actually do very easily.
I could imagine. It's a
Wait,
perfect. It's a
all
match
right,
made in
this-
heaven.
Our people will talk to your people.
Yeah.
We'll-
Our people will talk to your people. This is fantastic.
Thanks for coming on.
Thanks so much, Ed. We'll
Cheers.
talk to you soon.
Guys. See you
Bye.
later. Bye.